Hi all, welcome to another code snippet discussion. So today I've shared this code snippet which you're viewing right now on my screen into my Telegram channel. So this code snippet is going to focus more on the local variables and how the initialization happened to the local variable. And we have a conditional constraints in order to make this code snippet a little bit tricky. And we do have some few distractors out there, but let's see how we can eliminate those distractors out of this actual theme of the code snippet. So let's get into the action. So I'm going to bring up my IDE and let's go ahead and create a class called zooinfo, and let's fire up with main method, and here we go. So we have our base template ready. So what I'm going to do right now here is, first thing is I'm going to define an instance method. Okay, it's going to be an instance method because we're going to invoke this method on top of an instance of this particular class called zooinfo. So this zooinfo is going to have its own member called print zooinfo method. It's a member method or member function of this particular class. Okay, so right now I'm just using the same syntax of what we have seen on the code snippet image. So a private method, private void print zoo info, and it's going to carry a boolean parameter called is weekend. So it's a boolean parameter, and inside this method we are going to write some few logic, and that logic have to be understood more in detail to represent this code snippet's output. Okay, so I'm going to declare a first line of statement which is going to be a final variable. So final int, and the identifier name is going to be giraffe, and I'm going to initialize them with a variable value called 5, and stay attentive here. So this line number 6 is actually declaring a final variable. So final variable means we are making them to be acted as a constant variable. Okay, it's a constant variable, and it has a explicit initialization. Okay, explicit initialization. This is a very much important to note down. The reason I'm stressing here is because the whole code snippet depends on this local variables explicit initialization. So final makes the variable to be stayed as constant, and the value is explicit initialization, and we have the data type used here is int. Pretty good. So now let's move forward and declare another set of variable as intact as the code snippet. So here again I'm going to declare another final variable, but this time it's going to be a data type of long, a primitive data type called long, and the identifier is going to be lamer. Now if you look at the lamer variable, this doesn't carry any explicit initialization. There is no explicit initialization. So if it is not carrying any explicit initialization, means will it carry any default initialization? So since it's a long comes under the integer family of primitive data type, right? Integer family carries 4 major data types, starting from your short, the byte, short, int, and long. So long is the higher type of integer family data type, and this long variable is not carrying any explicit initialization. So will it carry a default value of 0? That's a big question that we have. Based on that, only we can go ahead and understand how to manipulate this code snippet. So okay, so right now we have a couple of variable. One is a variable which is explicitly initialized to value of 5. Another variable is not having any explicit initialization, and both the variables are standing as a final variable, means they both are constant variable. Now it's time for us to spin up a conditional statement by using an if, and we are going to bring in the boolean variable, the is weekend, to be passed as a parameter. Okay, so if you look at here, this is weekend is going to be passed on as a conditional check for this if, but this is a boolean, right? Either it should be true or false. So based on that only, we'll be able to execute the if statement, the conditional statement. So right now this if is weekend is going to carry a one-liner of statement where I'm going to say lamer equals let's say I'm going to give a value called 5 again, right? So what happens here is I'm sorry, there's a typo mistake, so let's go ahead and rectify that. So it is weekend, and here if is weekend, if it's going to be true, it's going to initialize the lamer variable to 5. If not, what's going to happen? So if not, we don't have anything to represent for if not kind of a logic. So meaning is we don't have else, right? We only have if as per the code snippet that we have seen on the image. So what we are going to do right now is straight away just go ahead and use a sysout statement, and this sysout statement is going to have the value to be printed. That's the giraffe and the lamer variable value need to be printed via the sysout statement. So let's go ahead and try to inject the giraffe variable, and as well as I'm going to give in some space between these two variable called giraffe and lamer. So great. Now here where we have a challenge. So now we are getting into the we are getting closer to the solution of the snippet. So you can notice that the lamer is ending up with some error. Means the compiler is trying to point out that this variable usage of this variable in the sysout statement is going to bring out some problem, and that's been notified at the compilation time itself. So we are good enough to understand that this lamer usage of this lamer variable is going to bring in some trouble for us. And who is intimating this? The compiler is intimating us. So anyways, let's come back to that error and let's investigate what's going to happen, what's going to be the reason for that error. But prior to that, I just wanted to write a statement from the main method, the entry level method, in order to invoke this print zoo info. So I'm going to create a new reference for the zoo info class, and we are ready with the instance of that particular class, and we can able to call the instance method, which is print zoo info, and I'm going to pass in a value called true. So this is exactly the same as like what we have seen on the image, the code snippet image. So now what is technically happening here? Let's come back to that. But prior to that, I'm going to invoke this print zoo info method by forwarding a parameter value called true to this is weekend. So if true means this statement is going to get executed, and make sure that the lamer is going to have a value called 5. That's fine. So we as in a developer can see that the value that this is weekend is going to carry true, but this is known only at the runtime, right? So during the compile time, these are only statements which are going to be compiled by the compiler, and the compiler will not get to know what the value of this is weekend is. So not necessary that it will go to this line number 15 and understand, okay, this parameter is weekend is going to take true. If it's true, then this if statement is going to get executed, and the lamer is going to carry a value of 5. So to that level of IntelliSense is not there for the compiler. The compiler will not look from the point of a runtime perspective, rather just approaches from a compilation time perspective. So for the compiler at this point of time, the compiler will never get to know whether this is weekend is going to carry a true or false. But what compiler will look at it is, it should either have it should have if and do some operations, else you do another operation. So that kind of statements is what the compiler will look out for. Okay, so now what's going wrong? So why we are facing this lamer variable with an error while we are trying to use? So it's pretty simple. Okay, local variables needs explicit initialization, mandate explicit initialization before it is getting used. Okay, before we use them, okay. So local variables need to be initialized explicitly. This lemur is a local variable which is not initialized at the time of declaration. While we are declaring, we haven't initialized this variable. Okay, but thinking that post the if condition gets satisfied, the lemur gets a value of 5. That's true. But what if in case if the if is not getting satisfied? If the if fails, if the if condition fails, then obviously lemur is not going to carry any value in it. And if in that scenario, if you are trying to use them to print something, or you're going to do some manipulations out of that variable which is not initialized, then obviously it ends up with a compilation error, because the compiler, while it is checking this line number 10, the compiler sense that this lemur is not getting initialized, even though we have a if statement, and after validating the if statement, the lemur gets the value of 5, but the compiler will not interpret it in that perspective. So they need a space where it has to be compiled. It has to be compiled only when it carries the else as well. So you need to have a default explicit initialization here, or you should have an else statement. Else lemur equals, let's say, 10. So now what happens here? We have a variable value, okay, called 10, right? So now this is getting initialized. The lemur gets initialized at the time of else. So means if the if is not satisfied, but the else will get executed. Okay, even if statement fails, the else gets executed. Now you can see the error is resolved, because by any chance the lemur variable will get initialized. If it is true, lemur gets 5, else lemur gets 10. So by any chance this local variable is getting initialized. If you don't have else, then there is no guarantee that the lemur is going to get the value of 5 or is getting initialized. There's no guarantee over there. So if I hover the cursor on top of this error, it clearly states that the local variable lemur may not have been initialized. May not have been initialized is what they are saying. It's not straightforwardly saying that it is not initialized. It states may not have been initialized, right? So that's so meaningful to understand. So what we do is, literally, during the time of declaration itself, we are trying to initialize. Okay, so when the value, the final value is going to be initialized at the beginning time, now there is another problem that occurs. You notice that this variable is final, right? When it is final, when it is already initialized at the declaration time itself, then you can't reinitialize. But as per the logic, based on the if condition, the lemur value need to be changed. In that case, either you need to remove the final, or you don't need to initialize them at the time of declaration and make use of an else statement to ensure by any means the lemur gets initialized. But let's keep this intact as a final variable itself. Let's not go for initializing at the time of declaration. Let's keep it uninitialized in the line number 7. Let's enable the else statement. Okay, I'm not using open and close curly braces because we go ahead with a one-liner of statement, if with one-liner of statement, and else with one-liner of statement. So there is no need for open and close curly braces to set up a block for if and else. You can also bring it up to the next line, so it will be more readable. Okay, so what's going to happen in the if is based on the condition, the lemur gets the value of 5, else not, the lemur will get the value of 10. Even if the condition fails, the lemur is going to get another value called 10. So the compiler is very comfortable, and the compiler is very confident that this lemur will get initialized by any means, and so there's no problem out there. So now if I go ahead and run this program, let's see what the output is going to be. Okay, so giraffe, I guess it's going to be 5. And since we have passed the value of true from your the calling section, okay, when you call the print zoo info method, we have passed true value, so that if true, the condition gets satisfied and the lemur gets the value of 5. If in case I'm marking them as false, okay, and this time we can expect the value to be printed as for giraffe it's 5, and for lemur it's going to be 10, because the is weekend is false. If it's not a weekend, then it's going to get into the else. So let's go ahead and see that as well. And now you can notice that the value on the console is 5 space 10. The 10 appears. So the understanding is, by any means the lemur variable, the local variable, gets initialized irrespective of whether the if is going to get satisfied or not, because we carry else statement as well for that, right? So by this way, it's a good practice to ensure that when you go for declaring a final variable without an without an explicit initialization, and you're going to initialize them on top of some condition, then better you have alternate initializations for the conditional statements like if and else. You need to carry, and that's the right approach in order to avoid the compilation errors. And also we are making it more standard. The code becomes more standard and it's more meaningful as well. Okay, since it's final, it needs it cannot be changed later. Okay, and this is not carrying any explicit initializations or default initializations as such. So it's the developer or the programmer who's bringing up that particular variable have to initialize them. Think of the different ways to initialize that local variable before you use it. That's very much important. I'm emphasizing it again here. Okay, before you use the variable, it has to get initialized. At the time of declaring, you need not initialize them, but before you use them, it has to get initialized. So in between the declaration and the usage statement, somewhere you need to ensure that the variable gets initialized. So this is what we have in store today for discussion according to the code snippet discussion. We'll catch up with another interesting code snippet in the next video. So thank you. Have a great day.